Good morning, good afternoon, and good evening to you all. My name is Andrew Glaser, and today I'd like to talk to you about how to look at a graph and then find the following polynomial equation. So what we need to do first is have kind of a simple model. So let's say we have this model. F of x will equal some leading coefficient c multiplied now by some factors. And I'm going to write this as x plus or minus. This is going to be a, that's some constant a, x plus or minus some other constant value b, right? X plus or minus then some other constant value of c, dot, 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 however many you want. And they're all going to be raised then to some power, some number, okay? I'll just write in a little number symbol. Not a hashtag, but a number. And these, I'm not suggesting, since I'm using the same variable there, that they're going to be the same number. I'm just trying to make it look simple, all right? And this c, since it's in orange, is different than that c, which is in black. All right. So let's now proceed with the problem. Now that we have this model, we are looking for basically three things. I'm looking for the coefficient, the leading coefficient. I'm looking for these constants in the factors, and then I'm going to look for the powers. Okay, three things. So first step I'm going to do is to identify the x-intercepts. Now these x-intercepts will help us locate, or not locate, but identify the constants in the factors, okay? So it looks like when you go here, you got an x-intercept right here at -3, so just write down x is equal to -3. You got another x-intercept here at -2, so write down x is equal to -2. You got another x-intercept over here at x is equal to +3. And then you have another one at, it looks like x is equal to 4, okay? Now, this turns out to be the way that we're going to find, like I said, those constants. So all you have to do now is whenever you locate your x-intercepts, you're going to take that value, the x-intercept value, you're going to change the sign of it, and you're going to plug it in for your a, basically, okay? Now, what I have here is I have a plus and minus sign, so if this was negative, you're now going to use the positive one, okay? So just erase the plus minus, make it a plus, change the a now to a 3, and that's all you got to do, okay? Go to the next one. If this is -2, then it's going to become a +2, so erase that, and write in a +2. Nice and easy, okay? Then if this is a +3, then you're going to go over here and erase it and make it a -3. And if you notice now, there's another one. So don't worry about it. Just put in another factor, okay? So there's going to be x then -4. And that has to be raised to some power again, all right? So we found those. The next thing I'm going to do is to identify the powers, okay? The next thing is to do the powers, or the hashtag symbol there, if you like, right? Power. Now, how do we determine the power of each of those? What happened to these dots? How do we determine the power of each of those factors? Well, it turns out that we have to identify the local behavior. All right, we have to identify the local behavior around those x-intercepts. Now, it's basically fairly straightforward. If the function crosses, actually literally crosses, like cross, okay? I don't care if it snakes a little bit. As long as it crosses, it goes from low to high, or in this case, high to low. You're going to have an odd power. Okay, that's telling you that it's an odd power. So if you notice, all of these actually cross, so they're all going to be odd numbers. All right, odd. If you had a case where it bumps, meaning but it has to come to the point, and as soon as it hits that value, boop, it bumps back down. Okay, if you had a little bump, then it would be even. But there's no bumps in this case. This is not considered a bump because the peak of the bump is not at that x-intercept, okay? So now it's like, oh, great. Okay, I know that they're odd, but is it 1, 3, 5, 7, 9? What odd number? Well, that's a good question now. Whenever they just kind of cross that x-axis, when there's no snaking, it's going to be a power of 1. As soon as you start getting that snaking going on, then it's basically going to be a power of 3 or higher. It's very difficult to, though, differentiate between a third and a fifth power. So also in terms of the question, it says least degree, right? So what's the least odd number you know? That's why they're telling you least degree. The least odd number you know is a 1. So every one of these x-intercepts will have a power. Well, the factor that's associated with those x-intercepts will have a power of 1. So you can go up here now, erase those power signs, okay, and just plug in a 1 if you want. And you don't even have to plug in the 1 because if there's nothing there, right, it's assumed to be a 1. So just leave it on out, okay? Then the last step here is now going to be to find the y-intercept of the graph. And why do we need the y-intercept? Well, we need the y-intercept because that's going to help us find our coefficient value, all right? So y is going to be equal to -3. And the reason for that is because for every y-intercept, you will know two unique things. You will know both the x and the y value. In other words, the x value of every y-intercept has to be 0. And the y value is going to be, well, the y value, -3. It also turns out, though, that you know something unique, two unique things about every x-intercept, right? Conversely, you know the x value, like for that point it would be -3, and you also know the y value would be 0, okay? However, though, we can't use these x-intercepts to solve for c. Why? Well, try it. Tell me what happens. Take a look in the comments below. I have a video out there on it. But take a look at the, just plug in -3 for x, plug in 0 for f of x, and tell me what's the value of c, okay? It's a trick question. So what we're going to do, though, is we have to use now this y-intercept value because it just works. The other one won't, all right? And again, you can go through the math to identify y. By the way, if you want to know how to, like, why the certain behavior, why odds cross and why evens bump, I got a video on that. I'll leave a link in the description below. I highly suggest you do view it because I don't want you to memorize these things. I do want you to understand, and afterwards, then you can memorize, all right? But because you do need a little speed on the test, and sometimes memorization will save you time, but I definitely do not want you to just memorize it right off the bat, all right? It's not going to help you learn anything. And remember, that's why we're all here, to learn. So what I'm going to start doing now is plugging in these values. I'm going to plug in -3 in for my f of x, right? So -3, because remember, f of x is the same thing as saying y. I'm going to leave my c there, okay? Then I'm going to plug in all my x's now go the value of 0. So instead of writing this step out, though, it'd be 0 plus 3. What does that work out to be? That'll just be 3. 0 plus 2, what does that work out to be? That'll just be 2. Right? 0 minus 3, what'll that work out to be? That'll just be -3. All right, and then we're going to have 0 minus 4, right? That'll just work out to be -4. Okay? So now, from here, what you can start to do is you can start, you can figure this out. You can use your calculator. You can just combine some terms that are similar, right? This looks like it's going to be a positive 12. Okay? -3 times -4. This looks like it's going to be a positive 6. And then what's 12 times 6? That's going to be well, c is equal to then 72, right? That's going to be 6 times 12. I changed the color along the way because I'm just thinking about the math, but the c is still there. It's still, right, I'm writing it just in black. But all you'd have to now do is just divide this side by 72. Okay? And then we're going to get now c is equal to -3 over 72. Now, if you want, you can leave it there. But that might be reducible, right? How do you figure that out? Well, you got to figure out if, how many times 3 can go into 72, right? So you can do your little long division if you want, right? You might not have seen this in a while. But 3 into 72, right? How many times does 3 go into 7? Let me move that down a little bit. So 3, 72. How many times does 3 go into 7? Well, twice. And then 2 times 3 is going to be 6. So you subtract. So that's 1, 2. And then 3 goes into 12 4 times. Oh, so 24, right? So this will work out to be -1 over 24 if you want it in the lowest ratio possible there. And that's now your value of c. So what you go over and do is you erase the c, and you're going to plug it down -1 over 24. Okay? This would also be the same thing as just dividing this whole thing by 24, putting your negative sign there. Or if you wanted to move the negative sign, put the -24 there. I mean, there's so many different ways you can write this now. All right, but I'm going to leave it like this. So -1 over 24, and that now, my friends, is the answer. Now you can factor this out if you want to put in standard form. You'll get an x, to the 4th power. All right, but you don't have to. I mean, this is the function, or this is the formula. Depending upon what form you need it in, that's just totally up to the question of the professor or whatever teacher. But I do hope this helps, all right? And that's all that there is to it. You just 3-step process, find the x-intercept, find the power of each of the factors, and then find the y-intercept to find your coefficient, and that's it. I mean, that's it, all right? Thanks for tuning in, guys. I really appreciate it if you can hit those buttons. Hit the buttons. That would be awesome. You know what buttons, right? Like and subscribe. I mean, why wouldn't you subscribe, right? Why wouldn't you like the video? I mean, this is This is amazing, right? Yeah, maybe even tell some of your classmates if it did help, okay? We really do appreciate it, by the way. I really do, all the support. And yeah, we wouldn't be here without you guys. So we try to produce as much content as physically possible, as you might see from our thousands of videos out there. And we not only have math here covered, but we have physics and chemistry as well, where we solve specific problems, because guess what? That's what you're going to see on your test. Problems, specific problems. So we teach the concepts through the problems, all right? And we try to help you become a better problem solver, not only in terms of, school, but a lot of these techniques overlap into life. And maybe I'll make some videos sometimes where I've actually used some of the stuff I've done in school to kind of, help me through problems or prove certain things to others, or whatever the case is. You never really realize that it can become useful to you, and it kind of does a little bit depend upon what you wind up doing in life. But, it's good to know things, all right? Knowledge is kind of potential power, right? Depends on whether you use that knowledge for good or bad. But guys, thank you very much for tuning in. Enough of my sermon, all right? This is Pastor Andrew, peacing out.